Hello everyone. So now that we've talked about how to rewrite the absolute value as a piecewise function, we're going to actually start computing limits with absolute value. So here I'm just noting to you, for finding limits of functions with absolute value, we need to rewrite the absolute value as a piecewise function, and then consider the left-hand and right-handed limits. But here, you do want to make sure you understand that when I'm saying for finding limits of functions with absolute value to do this technique, when you get 0 over 0, right? So don't forget about the fact that you do need to plug in the number that you're approaching into the function and make sure that you actually get that indeterminate form 0 over 0, right? Because even if it has absolute value, if you plug it in and get an answer, that's it. That's just the limit. So you don't need to do all of these techniques here. But of course, in the video right now, I'm going to go over ones where I am going to get indeterminate form 0 over 0. But again, it could be possible on class practice or tests and quizzes that you see a limit where you just plug it in and get the answer. So don't forget to do that. So now what happens here is when I plug in 0 in for x, I'm going to get 0 over 0, right? I'm going to get 0 over the absolute value of 0, which is still 0. So I'm going to get, again, my indeterminate form, 0 over 0. Okay, so now I'm kind of stuck at this stage, because here I'm just like, well, what do I do with this, absolute value of x? Like, what's going on with that? So I need to rewrite over here the absolute value of x using my piecewise function. So here we have that the input x is the same as the output when x is greater than or equal to 0. And then it's negative of whatever my input is. The output is the opposite, or the negative of whatever my input is when x is less than 0. Okay, so that's it written as a piecewise function. So now what I want to do is consider the left-hand and right-handed limits, right? So here I want to do the limit as x approaches 0 from the left of my function, and then I want to consider the limit as x approaches 0 from the right of my function. Okay, and then I'm going to write this one more time. The limit as x approaches 0 from the left of x over. Now I need to figure out which piece I should be using when I'm using 0 from the left. So here, you're looking for the piece that has x is less than 0, right? Because that's when you draw the number line. I'm having like my shaded region over here, right? So when x is less than 0, I can see that physically on the number line, and the part that's highlighted is physically to the left of 0. So when I'm approaching, as x is approaching 0 from the left, I'm going to use that bottom piece. So this is going to be x over negative x. And so when I simplify this, I get the limit as x approaches 0 of negative 1, right? Because these x's cancel. And so now you're probably wondering, well, what's the limit as x approaches something of a number? Well, it's actually just going to be that number, because here, if you can't physically like plug in, right, I can't plug in 0 like in for x because there is no x value there. So basically what this is you're basically taking a limit of a constant function. And so no matter what your input is, your output's always negative 1. But in general, just so you know, this is actually a rule here, like the limit as x approaches c of a constant k is just k, where k is a number. Okay, so that's like an actual limit property, but just so you can think of it as like a constant function, when you have a constant function, no matter what your input is, your output's always like that constant. Okay, so now I want to figure out which piece I need to use from the right. So I have the limit as x approaches 0 from the right of x over, and now instead of writing absolute value of x, I'm looking for that piece when x is approaching from the right. So the piece that I should use there is x, right? That top piece. So here I'm going to substitute an x. Now I'm going to simplify my limit. So x over x is just 1. And so based on my property here, oh, forgot to write from the left on that top piece, but same idea, this is just 1. Okay, so now ask yourselves, does the left-hand limit match the right-handed? No, it does not. So the limit does not exist. Okay, let's do another example just so you can see the process one more time and connect more with how to rewrite these piecewise functions. I have the absolute value as piecewise. But here again, if I plug in -1 for x, I'm going to get 0 over 0, which is my indeterminate form. And you notice that I have the absolute value of x plus 1, so I need to rewrite that as a piecewise. Okay, and at this stage you want to try to pause the video and see like if you can do this on your own. Okay, so now my input here is x plus 1. So my input is the same as my output when x plus 1 is greater than or equal to 0. And then I have negative of my input for my output when x plus 1 is less than 0. And eventually you'll see it as x is greater than or equal to -1, and you'll probably be able to skip that first initial step that I made there. But for now, you can write it out just to be convinced of where I'm getting like x is greater than this value and less than that value. It's coming from these equations here. I'm solving for x to get down here. Okay, so now, right, I'm considering the limit as x approaches -1, and I want to consider left-handed and right-handed limits. So I'm going to start with the left, the absolute value of x plus 1 over x plus 1. So now, looking at this second line here, so looking at this piece, which piece of the piecewise function should I use when I'm approaching -1 from the left? And so hopefully you say that it's the bottom piece, right? That negative times x plus 1. So I'm going to substitute that in for the absolute value of x plus 1. So I have negative x plus 1 over x plus 1. And now here you see that these x plus 1's cancel. And so I'm left with the limit as x approaches -1 from the left of -1, which is just -1. Now I'm going to consider the limit as x approaches -1 from the right, the absolute value of x plus 1 over x plus 1. So this gives me the limit as x approaches -1 from the right. And now I need to rewrite the absolute value of x plus 1 coming from the right now. So which piece should I use? Hopefully you agree and say that it's the top piece, x plus 1. So now I'm going to write x plus 1 in the numerator instead of the absolute value of x plus 1 over x plus 1. And so now these cancel to just become 1 from the right of 1, and so this is just 1. So now the left-handed limit doesn't equal the right-handed limit, so we get that this does not exist. Alright, I know that you're seeing a pattern where it seems like whenever there's absolute value, the limit doesn't exist. That's not necessarily true. So you do need to do this process out, even though for a lot of the problems it seems like that's the case.